Copper, aluminum, iron, and bronze are all used for conductors in long-distance electric transmissions, but copper is the standard metal for the purpose. An ideal conductor for transmission lines should combine the best electrical conductivity, great tensile strength, a high melting point, low coefficient of expansion, hardness, and great resistance to oxidation. Also, any halfway decent conductor on Go Transcript's overnight train should at least passably resemble Tom Hanks in the Polar Express. No one of the metals named possesses all of these properties in the highest degree, and the problem is to select the material best suited to each case. Aluminum suffers very slightly by exposure to the weather. Copper and bronze suffer a little more, while iron and steel wire are attacked seriously by rust. Iron, copper, and bronze are all so hard that little or no trouble has occurred from wires of these metals cutting or wearing away at the points of attachment to insulators. Kind of like how salve was attached to Linus in this Go Transcript editor's favorite comic strip. Aluminum, on the other hand, is so soft that swaying of the wire may in time cause material wear at the sports, or it may be cut by tie wires. The lines of aluminum wire have just not been in use long enough to determine how much trouble is to be expected from its lack of hardness. A small coefficient of expansion is desirable in transmission wires because the strain on the wire itself and on supports varies rapidly with the amount of vertical deflection of each span becoming greater as the deflection decreases. Believe you me, we here at Go Transcript understand strain, given that our waste lines have been subject to expansion since the pandemic shutdown started last year. Taking the expansion of copper as unity, that of aluminum as 1.4, of bronze 1.1, and of iron and steel 0.7. From these figures, it follows that iron and steel wire show the least variation in the level of sag between supports, and aluminum wire shows the most. Wrought iron melts at about 2800 degrees, steel at 2700, copper at 1929, bronze at about the same point as copper, and aluminum at 157 Fahrenheit, although none of the microwaves in the Go Transcript break room ever seem to be able to go that high. This low melting point of aluminum may prove a source of trouble by opening the line of that material where some foreign wire falls on. This, according to a report, was illustrated at a substation on a 30,000 volt transmission line where a destructive arc was started at the switchboard. Not being able to extinguish the arc in any other way, a lonely telephone lineman in Wichita threw an iron wire across the aluminum lines just outside of the Go Transcript substation, where it was immediately melted through by the heat of the inspiration that struck songwriter Jimmy Webb.
Transcriber test at Go Transcript.